video, we will describe the configuration of a basic wireless network topology that is commonly found in the Internet Service Provider's network. The basic ISP network architecture will be first introduced. A wireless backhaul implemented using Infinet Wireless units is represented in the picture. The last mile segment of the backhaul is directly connected to the end-user equipment, and it is commonly set in a point-to-multipoint topology to aggregate the traffic towards the POP sites. The practical implementation using the Infinet 2x2 product family in the sub-7 GHz spectrum is best fit for the last mile, as it offers flexibility, scalability, and short deployment time. The aggregation segment requires higher capacities, increased availability, and longer distances, which can be achieved by using the Infilink 2x2 or Infilink XG point-to-point products. The backhaul ensures the transmission towards the router that is connected to the ISP high-speed backbone. We can now introduce the ISP services like DNS, mail or web, and the hosted services, consisting of the file server farm, mail server farm, and web server farm. The basic rule is to use separate VLANs for each hosted server for security reasons. We will next see how to configure the Infinet units in order to ensure VLAN connectivity between the end users and the ISP servers. Before we get started, some basic knowledge will be presented. The trunk group is a switch group operating in trunk mode, and its purpose is to ease the configuration when multiple VLAN flows need to be transmitted to several customers. The trunk group is configured at the base station side, and it works as follows. The incoming traffic through the wired interface is sent to the trunk group, which in our case will be trunk 1, and it is further divided automatically into different switch groups with IDs that match with the VLAN tag of the packet. VLANs 101 to 104 are translated in the corresponding switch group IDs, as we can see in the animation. The in-trunk groups are created at the CPE side, and their IDs should match with the corresponding VLAN for each customer. The practical scenario consists of 3 R5000 units, 1 base station and 2 CPEs, connected in a point-to-multipoint topology. The customers behind the CPEs are logically separated from each other through the ISP network using VLANs. VLANs 101 to 104 will be assigned to customers for the data traffic, and VLAN 100 will be used for the management of the units. The customers behind CPE 1 are connected through a switch, and different VLANs are used locally. This helps ISPs to maintain a consistent network planning, even if some customers will need later to change their VLANs planning. Using Infinet CPEs, ISPs can easily perform any VLAN changes for their customers at the CPE level without the need to change the VLAN's planning set for the base stations and for the other backhauling links. In our case, CPE1 has to tag the traffic with VLANs 110 and 120 towards the customer, and with VLANs 101 and 102 towards the base station. The customers behind CPE2 require to receive their traffic untagged. The Ethernet interfaces must act in this case as access ports. Therefore, the VLAN tags must be stripped from the egress packets, and all inbound traffic will be VLAN tagged by the unit. To be noted that different services or customers can be connected to our unit through the 2 physical Ethernet ports without using any third-party switch. So CPE2 takes in this case the role of the switch, performing all the necessary frame processing. Additionally, we will configure QoS policies in order to divide the bandwidth of the base station between the CPEs. In this example, we will use a sector capacity of 150 megabits per second, which is less than the maximum available sector capacity of the base station. In our scenario, CPE1 requires 100 megabits per second bandwidth, which is split as 25% for PC1 and 75% for PC2. CPE2 requires 50 megabits per second, and the customers behind will receive 10 megabits per second in case of PC3 and 40 megabits per second in case of PC4. Let's begin with the configuration of the base station. All switch group IDs, VLAN tags, and IP addresses used in this video are demonstrative. Go to the Basic Settings page and open the Mac Switch section. The management traffic is by default included in switch group 1, so we have to remove it. Click on Remove Management to remove the SVI interface. Next, select the trunk mode for switch group 1. Let's create a new rule to specify the VLANs that should be processed by the trunk group. Click on Add Rule and add VLANs 101 to 104. Now click on Create Switch Group and add switch group 100 for the management traffic. Add the Ethernet and RF interfaces to it. Next, click on Create Management. You can see in the Network Settings section that the SVI 100 and VLAN 100 interfaces were automatically added. Since only untagged traffic goes through SVI, we need the VLAN interface in order to process the tagged traffic. Let's just input the management IP address 10.10.10.1/24. If we go back to the MAC switch section, you can notice that a rule to filter the traffic tagged with VLAN 100 was also automatically created. Now let's go to the Extra Commands section and configure the QoS policies. In order to implement the bandwidth allocation policies, we need to create a class for each CPE. Let's add first class 1 for CPE 1 with a maximum of 100 megabits per second. Now let's filter the traffic for the two PCs on different channels based on the VLANs used. Channel 1 will be allocated 25% of the bandwidth defined for Class 1, so this will give us the 25 megabits per second for PC 1. Channel 2 will be allocated 75% of the bandwidth, so that PC 2 can use 75 megabits per second. If you want to allocate additional bandwidth in the case that there is no traffic on the other VLAN, you can add the seal command with the corresponding percentage, in our case 100%. Similarly, Class 2 was added for CPE 2 and logical channels were created to filter the traffic of PC 3 and PC 4. The bandwidth allocation was also performed per channel according to our scenario. The configuration of the base station is finished, so I will click on the Apply button to save the changes. We can see that we lost management because I have no VLAN set, and we require VLAN 100 to access the unit at this moment. I will next show how to perform the configuration for CPE 1. First, remove the management. Because switch group 1 cannot be used for any of the data or management traffic, click on Remove Group to delete it. Create switch group 101 to match with the VLAN ID for the data traffic. Add the Ethernet and RF ports to it. Since we want to maintain a consistent network plan as explained, let's configure the RF and Ethernet interfaces to tag with the corresponding VLANs in each direction. This way, the egress packets on the wired interface towards the PC will be tagged with VLAN 110, and the egress packets on the RF interface towards the base station will be tagged with VLAN 101. Next, select the in-trunk operational mode and specify the switch group that processes this VLAN, which in our case is trunk 1, configured at the base station side. Don't forget to add a rule to allow both VLANs 101 and 110 to pass. Another switch group has to be added for PC2, and it should have the ID 102. The configuration steps are similar, so those were already performed. Next, create switch group 100 for the management access. Add the Ethernet and RF ports to it, and then click on Create Management. The configuration is similar to the one performed at the base station, just a different IP address must be input. The The last step is to go to the Extra Commands section for the QoS configuration. I have already performed this, and we can see the same rules like the ones created on the base station. However, these rules will apply for the uplink traffic, while the rules on the base station apply for the downlink traffic. Click on the Apply button to save the changes. We'll just review shortly the configuration of CPE2. Here, we can see switch groups 103 and 104 for the data traffic according to our scenario. The difference is that the Ethernet ports must be in access mode, so those were set as strip, in order to strip the VLAN tag for all egress packets. The RF interface should, on the other hand, tag with VLANs 103 and 104. Please note that in this case, you shouldn't specify any rule in the data switch groups. Another important notice is that since we have no rule on the switch group, we should set them on the second and third positions, after the management switch group. Otherwise, all traffic will go to switch group 103, and the management for this unit will not work. The configuration steps are finished. I have configured VLANs on the switch, so I'm now able to access the units using VLAN 100. Let's look at the traffic shaping section at the base station. We can notice that the bandwidth allocation policies are reflected for each channel according to the configuration settings. Let's now test the bandwidth allocation policies. Traffic will be generated using the iPerf tool towards all PCs at the same time, as we can see on the screen. The traffic is generated in downlink, so the base station should limit the bandwidth according to the QoS settings that we just checked. Let's see what happens when traffic is generated. In conclusion, we can see that the traffic is indeed limited according to the settings presented earlier. So this confirms that the traffic which is initially split from the server to the PCs using VLANs is further filtered by the base station towards the CPEs into different channels, according to these specific QoS rules. Let's now see the effect of the seal parameter. I will stop the traffic on VLAN 102. We can see that the traffic on VLAN 101, which is flowing through the same CPE, occupies now the entire bandwidth allocated for that CPE, which is 100 megabits per second. This concludes the scope of the video. Thank you for watching.